Hi, in this video we will start with measures of central tendency. We have 6 types of measures of central tendency and 3 types of partition values, and in this video we will concentrate on arithmetic mean and weighted mean. Here is a small part of the map of New Delhi. Here is RBI officers colony and here is AIIMS hospital. A car starts from here and it intends to move to AIIMS hospital. Now see, these are the readings we got about the car when it was moving. When it reaches this area, the speed was 20 km per hour, and here it was 80 km per hour, and here 10 km per hour, 10 km again, here is 50, 40, 60, like that, and ultimately it reaches AIIMS hospital when the last speed recorded was 10 kmph. Here is a chart of 13 locations where the data have been recorded, and if I ask you whether it was a fast moving car or a slow moving car, now by seeing these 13 different values of speeds, it is very difficult for finding out whether the car was a fast moving one or a slow moving one. So what we can do is that you add these values, divide by 13, and you get 38.46. This we call as average or mean. Now you can decide whether it was a fast moving car or a slow moving car. Now what this 38.46 is all about? It is actually representing on behalf of all these 13 values, right? And what advantage you can get from this mean? You can compare the fastness of this car with another car. Say a different car is also starting from RBI's officers colony and it is reaching to AIIMS hospital, the same route, but we record 20 locations with different values. Now if I ask you to compare which one is faster and which one is slower, then it will be difficult to find out. So what you can do is that you take the average of the second car, and if you find the average of the second car is higher than this first car, then you can say that the second car was faster than the first car, right? So we see that this 38.46, this mean, is actually somewhere centrally located from all these 13 data points, right? So that is central tendency. That all the data points in this data set linked somehow with a central value like this mean. Clear? Now before going into details about this arithmetic mean, we have to look after these properties. First, it must be rigidly defined and it should be liable for algebraic manipulations. That means whatever method you apply, the average result must be same in all cases. And here are other properties. One important property is the fifth one, that it should be possible to calculate even for open-end class intervals. Now if you want to have a good average, the open-end class intervals must be supported. That means, say, less than 20 is a first class, then 21 to 40 second class, then 41 to 60 third class, and greater than 60 will be the final class. Now this type of class intervals is called open-end class intervals, because on the first class you see that it is written less than 20, and on the upper side it is given greater than 60. That means it will start from 61 and it can go anywhere above 61, right? So if you want to have a good average, then your calculation must support this open-end class intervals, okay? And one more thing, your average should not be affected by extremely small or extremely large observations. These are called outliers. Outliers. Now what an outlier is, suppose there is a number 2, then suddenly you get to 80, then 82, then 85, then 90, say 95, and on the other side you see 550. So you see that this 80, 82, 85, 90 and 95, these numbers are very close to each other, whereas there is a long gap between the first number and the second number, and there's a long gap between the second last number and the last number here. So this is an outlier and this is also an outlier on the other side. So if you have this kind of data and if you have a good average, then this kind of data set will not affect your average. Okay. Now we start with arithmetic mean and we will deal with two types of data. one is ungrouped and the other one is grouped. Now what is ungrouped? The raw data what you have collected. Just in our previous example of the car moving, we have 13 locations and we have 13 different speeds at those locations. So this is an ungrouped data. That means whatever you have collected or whatever you have observed, all those data points without any manipulation have been presented here, right? And if you have grouped data, then you have the groupings like this, that the speeds between 0 to 20, then those speeds between 21 and 40, like that. Now you have to identify those speeds between 0 to 20. So this one is there, then this one is there, this one is there, this one and this one. You have got 5 speeds at these locations where the car's speed was between 0 and 20. So you write here 5. Next, you can count the speeds between 21 and 40. So if you go through this data set, then you will get 3 times. Okay, so this one also 3 times, and between 61 and 80 there were 2 times the car was managing this speed. This 5, 3, 3, 2, these are called frequencies. Frequency is nothing but how many occurrences does a specific interval appears in this data set. Okay, now let's start with arithmetic mean. First we start with ungrouped data, and for handling ungrouped data you have 2 methods. We start with method 1, and this is quite straightforward, that if you have n observations starting from x1 to xn, then you have this mean x bar as summation of I equal to 1 to n of xi by n. So according to our previous car moving data, you have 13 data points from x1 to x13. And you get to go like this, that summation of xi's, that is giving you 500, and you have the n's value as 13, so you get 38.46. We have done this calculation before. Now we go using frequencies. If fi is the frequency of the ith item ui, then you have the mean x bar as f1.u1 plus f2.u2, and it goes up to kth term. And on the lower side, you also have k frequencies, that is f1, f2 and fk, right? Now what this k is actually, it is distinct observation count. What is the meaning of this? You have x3 as 10, you also have x4 as 10, and here also x10 as 10 and x13 as 10. Now the speed 10 appears in 4 locations, right? Now this 10 is actually one of the ui's, right? So here you see, u1 is 10, u2 is 20, u3 is 30, 40, 50, 60 and 80. There is no 70 actually, so from 60 to 80. So we have 7 unique items from u1 to u7, and u1 is having the speed 10 and it appears 4 times. u2 is 20 and it appears 1 time. Okay, u3 appears 1 time, like that. So if you want to have this mean, then ui is 10, and how many times it appears? 4 times. So definitely you have to multiply this by 4. So when you are going without frequencies, then you are counting the same 10 4 times, right? But in case of frequencies, you bring all those 10s in one location like this, and you count it. So whether you go using frequency or without frequency, the same calculation is performed here as well as here. Right? Now one more thing, you should not be confused with this clustering of these 10s as a group. It is not a group actually, because the same items are here and those items have been brought in one location to count them actually. So this is not grouping. Now we started method 2. Here we consider an arbitrary point A and we go for the mean as A plus the summation of the differences between those data points and the arbitrary point by n. Let's consider the previous data set, and we take an arbitrary point A with 50. Now to find D1, we have to go like this, 20 minus 50, that is minus 30. So D1 is minus 30. Similarly, for D2, you have 80 minus 50, that means plus 30. Like this, you can have up to D13. Now if you see in a plot wise, then you see that your 50, that means the arbitrary point is standing here, and these are the different data points you have observed, and these gaps you are trying to find out, and these gaps are actually your DIs. Now what we have learned in method 1, we didn't consider any arbitrary point like that, but how it worked, you see here. In method 1, we are considering a point A which is equal to 0. That means your arbitrary point A may be anywhere, but the gaps between that point and your data points will yield you the same arithmetic mean. So here you go, A plus D1 plus D2 up to D13, and by n you just calculate this portion and get the result. Now if we consider frequency, and if I is the frequency of the item ui, then you have the x bar, that is mean, as a plus summation of fi dot di now by summation of fi. And this whole thing is actually equivalent to this, that is summation of fi dot ui by summation of fi. So here is our ui's. 10 is one ui, that is u1. This one is u2, u3, u4, like this. And we have 4 pieces of u1s, 1 piece of u2, 1 piece of u3, like this. And if you plug these values here inside, then you get this, and you compute this and you get the result as arithmetic mean. Now we talk about group data, and this is method 1. We have the groups like this, that how many times the car's speed was between 0 and 20. So we got 5 times in our data set. So we have written 5 here. How many times we have got the speed of the car between 21 and 40 kmph? We got 3 times. So here we have got 3 times, and between 61 and 80 we have got 2 times, right? Now this 5 is being shared by all the data points between 0 and 20. Also, this 3 is being shared by all the data points between 21 and 40. So to associate each frequency to a single value, we have to get the midpoint of these speed intervals. If we consider fi as the ith frequency, then that frequency belongs to the midpoint of the class I. And in this way, you get the mean of the dataset x bar as f1 times m1 plus m2 times m2, like this, and you go up to k times because you have k classes, and you divide this summation by the sum of the frequencies up to k, right? So in short, you can write like this. So you have the mean values as 10, then 30, then 50, and then 70. And if we calculate, then it will go like this, that 5 times 10, that means 5 is the frequency, this is f1, and this is m1, this is f2, this is m2, this is f3, m3, this is f4, m4. So you add these products and you divide by the frequencies, that is 13. So actually this summation of this frequency is actually equal to n, and you compute this numerical and get the mean of the dataset. Now you go for method 2, and in the method 2 we have an arbitrary point A as before, and we have the frequency fi of the relevant mi of that ith class interval. Okay, so we have this x bar as the mean equal to A plus the summation of the frequency of the first class times the difference between the arbitrary point and the midpoint, because this time our data point is actually mi, right? Because our modified data points are mi's, not xi's. So you get di by subtracting mi from A or subtracting A from mi, whichever you go. In both way you will get the same result. So in the short form you can write A plus summation of I equal to 1 to k fi dot di by summation of I from 1 to k fi. Okay, so here are some properties you will have for arithmetic mean. Now if you sum up all those deviations from their mean, you will get 0. That means if you have say 2, 3, 4, then you have the mean as 3 here, and if you subtract 2 minus 3, this portion, then you will get minus 1. This 3 and 3 will give you 0, so add it with 0, and this 4, 3 will give you plus 1, right? And if you add these, and you will get a 0. Next, the sum of squares or deviations from the mean is least in comparison to the same taken from any other average. What is the meaning of this? Sum of squares of deviations of the mean, that means minus 1 whole square plus 0 whole square plus 1 whole square. What it gives us is that minus 1 whole square is 1, 0 square is 0, and plus 1's whole square is 1. That means it gives us 2. Now the property 2 is talking about any other average. That means any other central values if you have say mean or mode or median. If you get the sum of square of deviations from that median, then that summation will be higher than the summation you have done using mean. So it will look like this, that xi minus x bar, so x bar is your mean, and this sum of squares will always less than equal to any other central values like this. And the third point is very important. Arithmetic mean is affected by both the change of origin and scale. That means if you have the data points based on the origin as 0, and if you have another mean point where the origin is somewhere else, say 10 like that, so those means will not be same. And if your measurement is about say kilometer per hour and you say you change the scale to miles per hour, then it will affect the mean. This arithmetic mean is affected very badly by outliers. Now we also talked about the open-end class intervals to become a good average, but this arithmetic mean will not help you in this regard. And if you have highly skewed distributions, then you will be in trouble if you use arithmetic mean. Say the distribution is like this, so your mean will be shifting towards the left side because this is rightly skewed distribution. It is highly skewed distribution, you can see. So in this case, arithmetic mean will not be a good choice. Next we go for weighted mean. So what is weight? It is associated with observations where the importance vary. The importance here may be defined as, for example, the number of occurrences, that how many times the word tiger is appearing in a text. Now if the word tiger is appearing mostly in the text, or the number of occurrences of the tiger and lion appears in the text, then you say that the text is talking about animals. So this is an example how importance can be quantified regarding your observations. So you can have this W1 as F1, what you have learned before. That frequency can be considered as a weight because frequency actually is counting the number of occurrences, right? So there are many other ways you can have the weights of those variables, and you go with the summation of this I equal to 1 to k wi ui by summation of 1 to k by wi. So it is actually very similar to the formula for mean of frequencies. So you can say that the calculation of arithmetic mean using frequencies is a type of weighted mean. Okay, so as our previous example, this frequency is weight 1, this one is weight 2, and this one is weight 3, like this. Okay, so we end this video on arithmetic mean and weighted mean, and we'll talk about median and mode in our next video.